Okay, okay, yes, okay. So I just heard your question before, and I mean, it's not my product, but it's made in Italy. It's built by a group of hackers in Rome, and they actually built this AI called Brian, and in which you can actually ask questions related to Web3. For example, here he's asking what is Uniswap, and then next question is please swap 10 USDC for ETH on Base, and the AI can actually do all the work and exchange for you and like guide you step by step in doing Web3 stuff. I don't know if these answer your question before. But then let's go back to the focus of this talk. So first of all, I'm Marco, and I'm a former Ethereum Foundation developer, and I'm now working for Argo, that is a spin-out of the Ethereum Foundation. And our team is developing, basically is the core developer behind Solidity. I don't know if any one of you here is a technician or not, but so this could be a technical talk. And it starts from this concept of the Ethereum's infinite garden. I don't know if any one of you have ever heard about it. So basically, Ethereum can be thought as an infinite garden in which there are a lot of gardeners taking care of all of the plants going on in this garden. And the cool thing is that no gardener is against each other, like in a typical capitalistic environment, because everyone wants the ETH, the basic value, to go up. So if we start fighting against each other and we start fires in the garden, then everyone is losing money. And so now let's see the map of this garden. And at the end, we have the core. So researchers and developers working directly on the core of Ethereum, developing, I don't know, the people that developed the merge. So when Ethereum went from proof of work to proof of stake, people working on cryptography, people working on very like consensus, yes, like core stuff of Ethereum. Then if we move a bit outside, we start looking at the tools. So we have frameworks for languages, we have some specific user interface, maybe not completely user interface stuff, but maybe the libraries that then developers use to work on user interfaces. That's also where I'm working on. And then at the end, we have the user interface. So all the applications that are working on in Ethereum, block explorers, so that you can check your transaction and going on. Okay, so here we can see there are researchers working on layer 2, EVM, nodes. Then we go again, EVM tooling, so we have languages and framework. And then we have user interfaces. We have block explorers, we have verifiers, and then we have Etherscan. And I put this image about Etherscan because in this talk is specifically about the problems of this decentralization at the edge of Ethereum. Okay? The edge of Ethereum, I mean the edge of this garden, okay? So in the middle, we have a strong decentralized core, but the more we go outside, and the less there is decentralization. Let's start from the first problem, block explorers. So Etherscan, that everyone uses, is actually a closed source software as a service, how do you call it? Software as a service. And most of the ecosystem actually relies on Etherscan itself. So many libraries, they actually fetch all of the information from the contracts, and also not libraries, but also libraries used by wallets. They are actually fetching all of this data directly from Etherscan. We don't know anything about Etherscan's code. So for example, we just had a very bad hack that relied on a vulnerability on Etherscan that no one knew, because their code is closed source. So security researchers cannot work on any of their code. And also, all of their data, so the database itself that contains all of the information of all the contracts, is completely closed. And if you ask them to get to like the possibility to get some data, then they say, oh yeah, we have an export of the last 5,000 contracts that is just chain and address. And then we have this API, but of course you have to pay for calling the API to extract all of the contracts information that again are one of the foundations of calling and interacting with a smart contract, but we'll see this later. Yeah, some nice thing that I saw is that user think that Ethereum itself is down just because Etherscan is down. And this is like mind-blowing from my point of view, like my point of view is the point of view of an hacker and a promoter of privacy and like decentralization. And this is like the opposite of, like exactly the opposite of what I'm fighting for. So what are some solutions? So like a user-friendly solution is just right now, you can do it now. You can start using Block Scout. That is simply an open source software as a service. You can deploy it yourself, and it supports a lot of blockchains, and it's already deployed for most blockchains. So you just go there, instead of etherscan.io, you type Block Scout, and you start browsing blockchains. And then if you're a bit more of an hacker like me, I also put the QR code. There is actually Etherscan, and I like it a lot. I like it a lot because it runs on your own device. So that's decentralization, okay? Of course, you need to provide an RPC. The RPC is basically the interface that a block explorer uses to communicate with the blockchain to extract information. But then we'll see later some information about RPCs. The cool thing is it's never down, so because you run it, so there is no problem and there are no vulnerabilities from outside. Then the second problem, source code verification. And this is exactly what I'm working on every day. So just to understand what's source code verification. On Ethereum and all the EVM blockchains, when you interact with a smart contract, you are calling a program like any other program in software engineering is like this, okay? So it's just a series of code for machines, okay? So you don't know what's actually going on. So it's a black box. It's a completely black box, and you have to trust it, okay? What source code verification does, we take the code that the developer uploads to source code verifier, we recompile it, and the process of compilation, it means to transform a human-readable code to a machine-readable code, okay? And that's what we do as a source code verifier. We take sources, we recompile them, and then we check if the output of this compilation is exactly the same as the code that is on chain. I don't know if it's clear. It's a bit technical, I know. So basically, I'll just repeat it once. On the blockchain, we have data in binaries, okay, like the one above. But us human, we understand only code like this. So my work is to create a connection between the human-readable code and the machine-readable code, okay? And then I publish this database online so everyone can check. I mean, not like end users, but security researchers can actually read the code of a smart contract instead of its bytecode. But here still relies that there is still a problem. Of course, Etherscan then, we're going to check again about Etherscan. But then, even if you decide to trust one of us, you're still trusting a single service, okay? Because we are the verifiers, Sourcify, BlockScout, RouteScan, we are the verifiers, and you are asking us, is this contract verified? What are the sources of this contract, okay? But of course, it's better to trust 4 services rather than only one closed source service. Again, Etherscan, closed source, closed source database, and also lock-in for chains. This is, from my point of view, this is completely madness. That's a short story. And we have, again, an Italian guy working on Avalanche. And Avalanche used to have Etherscan as their main block explorers. So all of their users, developers, verified all of the contracts on Etherscan. But at a certain point, they realized, oh, fuck, like, Etherscan is closed source. It's like the opposite of decentralization itself. So we want to extract our data from Etherscan. And Etherscan just said, no, these are our data. Okay? So chains themselves are locked in, like when you use Apple devices like me. It's like they are forcing you to use their own products. That's madness. What are the solutions for this? So first of all, we created a verifier alliance to fight this. We basically created a database that is completely open, and each of the verifiers, once a user submit a new contract source code, we store it both in our private database, private meaning of our service, not private itself. But then we also push this data to a shared database between all of us, so we can all learn from each other. We create standards. We are working together on source code verification libraries, such libsourcify, but I'm gonna show it later. And also we publish everything on IPFS. So all the sources can also be accessed by IPFS itself. I don't know if anyone here knows about IPFS and knows about smart bytecodes. Do you? You do? Okay, so I'm gonna actually demo something since I have a lot of time. Something nice about IPFS and Ethereum, sorry, not Ethereum, EVM. If you're using Solidity to develop your contract, and then you compile your contract with Solidity, something magic happens at the end of the bytecode. So Solidity automatically appends a file, an hash that we call CBOR aux data, and inside this aux data actually relies an IPFS link, and this IPFS link contains the metadata file, and this metadata file actually is a collection of contracts information. So for example, you need the ABI. Oh yeah, I'm a software developer, I need the ABI. I will use just a library that fetches data from Etherscan. But while at the same point you have the ABI right inside the bytecode itself.
I loved IPFS when it was new, and I'm a developer myself and try to incorporate it into my product, but it failed so often and it was so slow. So is it really on the edge of usable?
Yeah, so as any other decentralized technologies right now, I think in the last couple of years, it improved a lot. And also notice that we are not only, like Solidity is not only storing links to IPFS, but also to Swarm. There is another technology, probably less stable than IPFS, but still, if like we make sure to pin all data on IPFS, so it's mostly available. We experimented, and in the last years, it's going pretty well. You can try. If you find a verified contract, you can actually try. From our point of view, it's quite stable. So yeah, basically, I just wanted to show you this file, and also notice that at the end, you also have the sources with the full source here. It's either the full source or another link to IPFS to the source. Okay, let's go back on track. That's why publishing on IPFS is very comfortable, because it is accessible directly from the bytecode. Of course, sorry, I didn't say that, you still need to verify the bytecode itself, because someone can put anything in that CBOR aux data at the end. So you still make sure that the contract is verified. Okay, and then We were discussing about trusting services. Okay, so we are still not completely decentralized. We are still federated, so we have to trust a specific service. But then there are some researches going on that I'm actually following. And actually this slide is a bit old, because this part on the left was actually completed in the last month. So in the last month, we actually successfully had the first edge verification. So what I mean by edge verification is executing verification directly in the user's device. And we decided to focus on the most used device, that is the browser. So now verification can be executed directly in the browser. And on the right, it's like a bit of a more difficult topic. I'm not a zero knowledge researcher, so I don't have the, I cannot work directly on that. But now I actually wanted to show you an example of edge verification that it's just a click away. So here I'm running Otherscan on my machine, and I'm actually not using an RPC on my device, but I'm using a, I don't know, quick node RPC. So I set it up in a minute, 5 minutes, okay? And here you notice on, sorry, let's go, because this is I'll show it to you like this. If I click contract over here, normally I get all of the ABI, I get the sources, okay, I get the sources, like Etherscan, okay? But then here, this is an experiment that we have going on with Otherscan, with the Otherscan team. And this has actually called libsourcify directly in the browser. It downloaded the sources from our database, not from IPFS, because it's faster and more reliable. And actually, maybe the answer to your question is, you don't even care where you get the sources, as long as you get the sources and you use the sources to re-verify your contract. And so here we actually executed the same code that is running in Sourcify server, but on the browser. And here the user can, before interacting with a smart contract, can re-verify on the fly.
Does it mean that that is a JavaScript library running inside? Does it mean that it's a JavaScript library running inside the browser? Or which language? Or
No, there is Solidity. They deploy also a version of Sol-C that is built with WebAssembly.
WebAssembly.
So we are calling the real Sol-C, the real one.
Okay.
And actually, there are some experiments. There are already a full virtual machine running on the browser. And so we could potentially also execute Viper contracts, because we don't support only Solidity contracts, but also other languages. Okay, that's the demo. It was fast, but it was good that it was fast. That's the whole point. Okay, then let's focus on the last problem. RPCs are centralized. So RPCs basically are, every time you interact with the blockchain, you're not interacting directly with the blockchain. You are passing through a node hosted by someone else, okay? Of course, the blockchain is built to create an intrinsic and like technological trust between you and the node and the person that is running this node. But what can happen, and has already happened, is that governments, for example, can censor specific calls to specific contracts. For example, the Tornado Cash contract that was used to be hidden on chain, now a lot of RPC based in the States, they simply censor you, okay? So I think it's opposite to the ethos of Ethereum itself. So everyone is the same, everyone can do whatever, okay? And then there is also a big problem of single point of failure. So if one of these RPC is down, then a lot of applications, they go down instantaneously, even if Ethereum is alive, because Like there are not many chances of Ethereum being down since it's decentralized. So what are the solutions? Again, we have local RPC that is called Helios. It's written in Rust. And it's super cool because it syncs. It doesn't have to sync. It's not a full node. It's not even a partial node. It's just like it uses an existing RPC. It synchronizes the state with the RPC, and then from that point on, you can use it as a fully local RPC. So from that point on, all the transactions that you do are totally independent from a centralized RPC. So if you combine Helios and Otherscan, you know that you are really using blockchain how it was supposed to be used. And here, just another small consideration. Now Web3 grew a lot and thrives a lot. And in the last years, with account abstraction, it became very easy for users to use the blockchain. Okay, but here the problem with account abstraction is that you successfully abstracted away all of the decentralization weird user experience from the user, but you hidden it in the background, and now the user doesn't even know what's going on. So all of the trust that you had, like that forced you to sign a transaction via your ledger, your cold wallet, whatever, now it's completely lost because everything runs in the background. What are the solutions? There are no solutions, I think, because if we want the blockchain to be used by everyone, we cannot force the user to sign everything with a wallet. We cannot force the user to use a private RPC. We cannot force the user to use a local explorer, and we cannot force the user to verify sources local. Okay, so the only solution would be to, and here I come just to my idea, but it's just an idea, so my proposal is a completely specialized browser with limited actions. And it has a very friendly user interface, but everything is like runs locally, and it cannot interact at random with any Web 2 or Web 3 service. No, Web 3 service, yes. Web 2 service, no. So it builds the UI automatically using contract information, because we can get it via local verification from libsourcify. Then it can communicate with an integrated local RPC using Helios. And so every time a contract for some reason wants to do an HTTP interaction, it warns you and it says, oh, this contract needs maybe an image from this website. So do you want to download it or not? Maybe you can say, yes, trust all. So you trust this contract and it can do whatever. And then at the end, smart contracts owners can integrate some custom UI to give specific, like a custom UI to the contract itself. But again, you are forced to use verified modules to build it. And MetaMask kind of did this with snaps, but it's a project that slowly, like no one was using it. So I see that sometimes that there were experiments to build something like this, but probably people don't care enough about these problems. So why building something like this if people don't care? And that's my talk.